Okay, welcome. In this video, I'm going to be working through Multivariable Calculus Homework 1.1, which is really just kind of a set of practice problems about what did we learn about last year, derivatives and integrals, really. Okay, so the first kind of set of problems, I've got you a table and a graph. And while the table and graph problems are not going to be nearly as prevalent this year in multivariable calculus as they were last year in AP calculus, it's still a good way to, practice our derivative rules, practice our integrals, all that stuff. Okay, this is the graph of g. G prime of 1 is the slope of the graph of g where x is equal to 1. So I'm going to need to, figure out what's kind of the rise and the run here. And I'm going to say, well, it went from the point 1, 2, 3, 4, 5, 6, so 0, 6, to, say, 2, 0. That's 2 points I know that are on it. So if I go from y2 minus y1 divided by x2 minus x1, I'll get negative 3, which is going to be the slope. Okay, so that's how we would find the slope of a function where we can see the graph and it was linear. Number 2, I'm just going to probably be copying these problems here and let's use something else. Yeah. So for number 2, it's the integral from 2 to 5 of f double prime of x dx. Okay. And so we'll do that by first finding an antiderivative. So that would be, f prime of x as x goes from 2 to 5. So that would be f prime of 5 minus f prime of 2. And that's going to be 2 minus negative 2 is going to be 4. And that's just kind of an old-fashioned using the fundamental theorem of calculus type problem along with the table. Okay, we can do that. Number 3, if a is x cubed f of x, find a prime of 2. Okay, well, a of x equals x to the 3 f of x, right? Yeah. Okay, so a prime, I'm going to use the product rule. That's going to be 3x squared f of x plus x cubed f prime of x. Okay, so a prime of 2 is going to be equal to, so 3 times 4 is 12 times f of 2 is going to be 8 plus 2 to the 3 is 8 times f prime of 2 is going to be negative 2. Okay, so that's 96 minus 16 is going to be 80. Okay, number 4. Oh, you can't see number 4. That'll be all right. So number 4, b of x is 2x divided by g of x. Okay, if I'm going to find the value of b prime at a particular point, I need to find an equation for b prime, and that's going to be bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Okay. So if I'm plugging in 1 to b, or to b prime, okay, so b prime of 1 is going to be equal to g of 1 times 2. G of 1 is going to be up here, that's 3. So that would be 3 times 2 is 6, minus 2 times 1 times g prime. Okay, we already found that g prime of 1 is negative 3. So minus 2 times negative 3 is negative 6. Okay, divided by g of x squared, well, g of x was 3, and so we're going to have, that'll be 9. So this would be 12 divided by 9. 4 divided by 3. Okay. Number 6 is, all right, well, so c of negative 4 is going to be the integral from 0 to negative 4. I'll actually scoot that over so we can look really fully at that. So the integral from 0 to negative 4 of g of t dt. Okay. That's, 0 is greater than negative 4, so I'm going to actually just make that the negative of the integral from negative 4 to 0 of g. Okay. Meaning that, okay, I can integrate from -4 to 0. It's going to be the amount of area underneath the graph from -4 to 0. And so I think I'm going to do this as a rectangle, and it's got a width of 4 and a height of 2. So that has area 8. So this is the negative of 8 plus a quarter circle. Okay, so that's 1/4 of pi times radius squared. Well, the radius is 4 there. And, well, that would be, an AP calculus, a safe place to stop. I feel like I might need to go a little farther than that, though. So that would be a quarter of 16, that would be 4 pi. So -8 minus 4 pi is going to be the value of c of -4. Okay. All right. So if that's c of x, then c prime of x equals g of x, and c double prime of x is equal to g prime. I guess that might be the next one. But is it? No, both of these are number 7. So c prime of -4, that's equal to g of -4, which I can tell from the image is just 2, because it says the point -4, 2 is on there. Okay, and then c double prime of -4 is equal to g prime of -4. And that doesn't exist because that's a sharp corner, right? The slope goes suddenly from being, I don't know, whatever that is. It looks maybe like a slope of 1. And it goes suddenly from a slope of 1 to a slope of vertical. And that's not going to be something that can happen continuously. So we say that one fails to exist. Okay. And, okay, yeah, that's all for number 7. Okay, number 8. If d of x is g of f of x, okay, then what is the value of d prime of 4? Okay. Well, that's where I'm going to take the derivative of the outside while leaving the inside the same, and multiplying by the derivative of the inside. And so I realized since I wrote d prime of 4, I didn't have any room to write d prime of x, and so I just kind of put the 4 in wherever I would have put x, right, when I was taking the derivative. So that's going to be, what is f of 4? F of 4 is equal to 3. Okay. So it's equal to g prime of f of 4 equals 3. G prime of 3 doesn't exist. What was I thinking? Hold on. Did I miss something here? G of f of x, f of 4 is equal to 3. That's a disappointment. Oh well. Yeah, that's really sad. Okay, g prime of 3 fails to exist, so this whole thing doesn't exist. Unless you can't see what it would be that I would be missing here. That's a shame. If I have missed something on that problem, you just let me know about it, please. All right, number 9. Find the integral from 1 to 5 of x f double prime. Okay, and I might actually, because this one's going to require a little more algebra. I'll go back to the table in a second. Okay, so what's this one? Number 9. 1 to 5 x f double prime. I'm going to let, okay, ILATE isn't going to really work. This is going to be UDV because I don't see anything being anything else with multiplication, right? No composition of functions, nothing, not fitting the UDU pattern. So it's going to be UDV. And, okay, while I know the antiderivative of x and I know the antiderivative of f double prime, if you look at the table, we have information about f prime, and f double prime. We don't have anything about f triple prime. So I would not recommend choosing u equals f double prime of x. I think it's just only going to get worse. The thing to do is let u equal x and dv equal f double prime of x dx. Okay, so that du is dx and v is f prime of x. And we know that the integral of u dv is equal to u times v minus the integral of v du. Okay. So now what I'm going to do is it's going to be u times v, so x f prime of x, And we are going to let that run from 1 to 5 minus the integral from 1 to 5 of v du. And this is something that we're going to be able to compute, right? So it's going to be 5 times f prime of 5. And f prime of 5 on that table, well, you can see that's 2, right? All right, so that's 5 times 2 minus 1 times f prime of 1 is another 5. I might throw boxes around this just so it's not, I don't make some sort of error. The integral of f prime from 1 to 5 is going to be f of 5 minus f of 1. Well, f of 5 is looking like negative 1, and I'm going to subtract 4 more, so negative 1 minus 4. Okay, this is definitely a number that represents the integral, but I feel like we can do a little better. So it's 10 minus 5 is 5, minus, that's going to be negative 5, and that's going to be 10. Okay, appears that I think I've skipped one. Yeah, I don't see anywhere on my scraps of paper. I don't remember doing number 5. Pardon me. This really clearly indicate that I'm working number 5 right here. It's going to be, let's see, the integral from 0 to 3 of g of 2x dx. Okay, this one, it's got a composition. It's got the 2x inside of g of x, or inside g, and I'm going to let, so it's going to be u du. And so I've got u equals 2x, and du is 2 dx. I don't have 2 dx, I have 1 dx, so dx is half of du. And I'm also going to need to convert my bounds of integration. Okay, so when x equals 0, that gives me u equals 0. And when x is equal to 3, that gives me u equals 6. Okay. So now, after my change of variables, I'm going to have this equaling the integral from 0 to 6 of g of u times dx is half of du. So I'm going to write the half there and the du over here. Okay, but the integral from 0 to 6 of g of u du, that's the exact same thing as the integral from 0 to 6 of g of t dt, same as integral from 0 to 6 of g of x dx. It's just the amount of area under the graph of g between x equals 0 and x equals 6, or whatever equals 0 and whatever equals 6, right? So we're going to find the area of this triangle. That's 2 times 6 is 12, divided by 2 is 6. Okay. And then this has an area of 1, 2, 3, 4. And 1, 2, 3. Okay, so that would be a 4 by 3 triangle. That's, oh goodness, that's also going to have an area of 6. So I have 6 and negative 6, so it's 1/2 of 6 plus negative 6. And you might see that's going to be 0. A lot of work to get to 0, but it's all right. It wasn't that much work, really. Okay, so I did the integration by parts. I don't recall doing number 10, so I'm going to just jump in and do that one right now. And okay, integral from 1 to 2, x f prime of x squared. All right. Now this one is going to be u du because I see the derivative of x squared is proportional to x. Okay? So I'm going to go over here and I'm going to let u equal x squared, so that du is 2x dx. I don't have a 2x dx. I have an x dx, so I solve for x dx. And that's equal to half of du. Let's go from x's to u's. I'm going to say, well, x was 1 to 2. So u will be x squared, and u will go 1 to 4. And now I'll be ready to change my variables. I'll be integrating from 1 to 4. Okay, f prime of u, and x dx is half of du. So I'm going to put the half here and the du over here. And yeah, now I'm ready to go. So this is 1/2 of anti-differentiate, plug in top, plug in bottom, subtract. So that's half of f of 4 minus f of 1 is going to be 3 minus 4. And that's going to be negative 1/2. Okay, so that was number 10. now we've got some more algebraic problems. Zoom back out. Write an equation for the line tangent to the graph of f of x equals square root of x e to the 4 minus x. I'm wondering, do these have anything to do with each other? No, they don't. Okay, so that's okay though. Write an equation for the line tangent to the graph of f of x at x equals 4. All right. Well, first I'm going to need a point. Okay. And that would be f of 4 equals square root of 4 is 2 times e to the 0 is 1, so this is 2 times 1 is 2. All right. Okay, f prime of x is equal to, all right, I'll take the derivative of square root x first. That's 1/2 x to the negative 1/2. Leave e to the 4 minus x the same. Then I'll add in, leave square root x the same, and take the derivative of e to the 4 minus x. Well, that's going to be e to the 4 minus x multiplied by -1 for the chain rule, so I might just take that from a positive and take it to a negative. For the chain rule on that negative x right there. Okay. Now, f prime of 4 is going to be 1/2 times the negative half power is 1 over the square root. Okay, so we got that. E to the 0 minus the square root of 4 times e to the 0. Okay, so I've got 1/4, because, yeah, 1/2 times a half, minus 2. And so I know that's -1 3/4, but I feel like we can do a little better than that. 2 is 8/4, so I take 1 and or 1/4 and I subtract 8/4. I get -7/4. All right. And so my equation okay. And there you have it. That's good old-fashioned tangent line problem. All right, now we're talking about the minimum value of g of x equals x e to the 2x. And, okay, the thing about this one is when I say the minimum value, we're implying over the set of all real numbers. But I think what I'm going to do is I'm going to kind of just go in and do a little bit of analysis on this one and just show you what's going on with g. And the whole problem set was supposed to be a reminder of the stuff that we learned about last year. And the first thing is if you want to find a minimum or a maximum of something, you take its derivative and you set it equal to 0. So I'm going to do that right now. Okay, g prime of x equals, take the derivative of x as 1, leave e to the 2x the same. Then leave x the same and take the derivative of e to the 2x. Well, that would be e to the 2x multiplied by 2. And, well, there I have it. I've got g prime of x. And if I want to know where this equals 0, well, I'm going to have to solve this by factoring. Okay. So I'll factor out that e to the 2x and get 1 plus 2x equals 0. And so g prime will equal 0 anywhere either of these is 0. Okay, e to the 2x is never 0. 1 plus 2x would be equal to 0 if 2x was equal to -1, which would be x is like -1/2. So I'm going to go over here and I say, well, I have -1/2 is the only critical point I've got. It's the only 0 of the derivative. Okay. And the derivative here went from, well, let's see what happens when I let x be more negative than -1/2. Like, I don't know, -10. Okay, then I have e to the -20, which is a very small number, but it is still positive. E to anything is positive. E to any real number is going to be positive. And then, but if I have -10, I'll have -20 plus 1 is -19. And take a negative number multiplied by a positive number, I know I've got a negative. Okay? But then if I let x be 100 or something, well, I know I'll have positive times positive. There we go. Okay, now the derivative went from negative to positive at x equals -1/2. Okay, that means I've got a minimum there. Okay. So I'm going to say g has a minimum at x equals -1/2. Okay, because the derivative went from negative to positive and the function went from decreasing to increasing. Okay, it wants to know the minimum value of g of x. Okay, well, if you think about it, it's got a negative slope up until x equals -1/2, and then it's got a positive slope after. So that means if I was to go back towards, let's say negative infinity from negative 1/2, I'd actually be going up, right? Because as I move to the right, it's coming down. Okay. And then after negative 1/2 is just increasing, so it couldn't be a minimum after because it's increasing. So I really think that g of negative 1/2 is the really only place I could have the minimum value of g. So yeah, g of negative 1/2 is going to equal, I don't know why I was having I know why I was having a problem. I was looking at number 11. It's like, how am I going to put negative 1/2 into square root x? So x equals, or x e to the 2x. Okay, that is the minimum value of g. But if we look at this and we say, hey, what happens when x goes to negative infinity? The limit of g as x goes to negative infinity is going to be 0 because exponential grows faster than polynomial. But so that means that I might actually draw you a little picture of this. I know x e to the 2x is equal to 0 and x equals 0, so I'll just put that there. Maybe this is x equals negative 1/2. And since I'm saying that it's got a horizontal asymptote of y equals 0, as x approaches negative infinity, then we're going to say it probably goes like that. I imagine that's what the graph of x e to the 2x looks like, where the y coordinate of that point is negative 1 divided by 2e. Okay? And I think that's all I'm going to say about this example. That was a good example, but we'll come back and talk about absolute extreme at a different time. That'll be great. Okay, find the particular solution to the differential equation. Okay, this is the separation of variables. I know somebody asked me in class if I could do one of those. I completely forgot, but luckily I put it on this practice set. So you'll get your practice either way, whoever you were. Okay, as much as possible, try not to copy the problem. That was a waste of time, but it's all right. I'm going to do y to the negative 2 dy is equal to cosine x dx. I need to use separation of variables, right? That's how we find a particular solution to a differential equation in AP Calculus. Okay. In this class, we're going to learn about all sorts of other techniques to find particular solutions to differential equations. They'll be way better than, I don't know if it's better than separation of variables, but it'll be more diverse than separation of variables, which is the only thing we had in AP Calculus. I don't know about you, but I felt like it got a little bland. Okay, so we're going to anti-differentiate both sides of this. And, if you said this is 1 over y squared, that's cool, it's the same thing. But you got to make sure that you're not telling me that the antiderivative of 1 over y squared with respect to y isn't the natural log of y squared. That doesn't work. Okay, just take the derivative to check yourself, and that's not going to be valid. Antiderivative for this is we use the power rule. We add 1 to the power and divide by the new power. And that's equal to antiderivative of cosine x is sine x, and I don't forget my plus c. Start solving at y. Okay. And so I think I'll actually just move that up. And so y is equal to negative sine x plus c to the negative first power. Okay, now they said that when x is pi over 6, y is equal to 1. Okay, so y equals 1. Right. 1 is equal to the negative sine of pi over 6 plus c to the negative first power. Okay, well I know that 1 is going to be 1 to the negative first power, so I need negative sine of pi over 6 plus c to equal 1. Okay. Okay, pi over 6 is not very far up. Okay, so that's going to be where the y coordinate is a half. Okay, and so it'll be negative 1/2 plus c equals 1. So c has to be 1 and a half. So it'd be 3/2. C equals 3 divided by 2. And then kind of, my conclusion is the particular solution is y equals negative sine x plus 3/2 to the negative first power. And that's how we solve the separation of variables problem. Oh, here it is. suppose the line y equals 2x minus 5. This is a good problem. I need to use this in my AP calculus class. I think I used one like this at some point in the year, but it's been a while. This is a good one. I like this one. Suppose y equals 2x minus 5 is tangent to the graph of f at x equals 3. That's actually giving you a couple of different pieces of information, both somewhat disguised. Okay, the slope of the tangent line, we know what that is. Okay, that means that f prime of 3, that's what f prime means, the slope of the tangent line, and that's going to be equal to. Okay, the thing about tangency is that they got to have the same slope and they got to have the same point, right? They got to share a point. So if they share a point, then it's going to have the same y coordinate. So whatever I get from this y when I plug in x equals 3 is the same thing I should get from f when I plug in x equals 3 to maintain the condition of tangency. So f of 3 is equal to 2 times 3 is 6 minus 5 is going to be 1. Okay. And now there's going to be other questions. Yeah, number 14. H of x equals cube root of f of x. Okay, and write it like that. Find, okay, h prime is going to be 1/3 of, leave the inside the same, f to the negative 2/3, multiplied by the derivative of the inside, which is f prime. So I'm going to say h prime of 3 is equal to 1/3 of 1 to the negative 2/3, which is going to be 1, multiplied by f prime, which is going to be 2, and that is in total 2/3. And then what's number 15? If f equals 0, this is a good one. I think it's not a guarantee, right? This would suggest if there was some sort of point of inflection between x equals 2 and x equals 3, then, this wouldn't be true. Assuming, a constant sign of the second derivative, I think what I want, I'm not going to answer this question. And I'm going to tell you, if you need support on it, to come talk to me. But I think that y'all can figure this one out. What I want you to think about is concave up means that the curve sits above the tangent line. And concave down means the curve sits below the, pardon me, I said it backwards. All right, I think if I'm saying it backwards, I should probably just work the problem. All right. So at x equals 3, I'm at the point 3, 1. So I am going to do this one. It's got a slope of positive 2. So it kind of looks like that. Which means that the tangent line is going to be here at x equals 2. Say that I just moved over 1 in x. At x equals 2, y is going to be negative 1, right? At least on the tangent line. Okay, so that's what I would expect f of x or f of 2 to be based on the tangent line. But I know for a fact that f of 2 equals 0. So that means maybe I'll use red for f. Black is the tangent line. And so that's the point 2, 0. Okay. And that to me means, provided that there's not some sort of point of inflection between x equals 2 and x equals 3, that it's probably, in order for it to be, tangent there, it's probably concave up. And so it would suggest that f is concave up based on this whole scenario here. That's all I got for you for this problem set. Thanks for watching.